Bless you. So this is what the first batch of problems is going to look like. I can make it a little bit bigger. It says answer the questions about the polynomial. So polynomials are, I was going to give you an assignment on like what is and is not a polynomial. Polynomials are basically anything, any mathy thing that just doesn't break a particular rule. And basically the rule that gets broken the most is if you ever see a variable in the exponent, then it's not a polynomial. But I'm not going to give you any of those. I'm going to bypass that part of it and just cut right into everything you're going to see as a polynomial. So like x plus 5 is a polynomial. 12 is a polynomial. X squared plus 32x minus 52.6 is a polynomial. I mean, basically any mathy sort of thing you could possibly think of is a polynomial. So what we're going to talk about today isn't so much what is and is not a polynomial. We're going to talk about the vocabulary, so that, because as you and I spend now the next few weeks talking about quadratics and cubics and quartics and trinomials and all that, I don't want to have to stop every day and talk about like, what do I mean when I say, hey, write me a quadratic trinomial? So we're going to focus more on the vocabulary side of things. So anyways, take a look at this polynomial here. Do you see all the question boxes at the bottom? So like if I were doing this problem, the first thing it says, the expression represents a blank. I click the drop down and you all see how there's a fraction, but the fraction doesn't contain a variable. So I'm not too worried about that. But you do see the x, right? Does x have an exponent? What is it? Now that's not called an exponent. That's called a coefficient. The number that multiplies in front is not an exponent. That's a multiplier, again, called a coefficient. Does x have an exponent? It does. You just can't see it. It is 1, right? And so anything that has x to the 1 as its highest power, don't worry, we're going to put all this in our notes in a minute. I would pick linear. So linear is a 1 degree, we say. And then it says, how many terms does it have? A term is any chunk of the polynomial that's separated out by plus or minus. So in this case, you see how there are 2 terms, like 1/6 is a term and 3x is a term. And again, I know those are called terms because the plus sign says so. So anytime you see a plus or a minus, it's breaking things up into terms. So for this one, I would select it has, or I would pick 2 terms. The constant term is the term that does not have a variable with it. So what would I say is the constant term? 1/6. The constant means in English and in math something that doesn't change. And 1/6 never has a chance to change because it doesn't have any x to tinker with it or to make it get bigger or smaller. The leading term is 3x. And we'll talk more about this too. But in order to make decisions about a polynomial, we have to put it in what's called standard form. So I would always put the highest degree of x first. So the 3x I would have to put first, and then the plus 1/6 I would have to put second. And so even though it looks like the first term is 1/6, we can't make a decision based off of that. We have to put it in the correct order first. So the leading term is actually 3x, that entire thing. And the leading coefficient, do you remember what I said earlier? The coefficient is the 3. So the number in front is called the coefficient. And if it's the coefficient of the first term, then we call it the leading coefficient. So we would say that the leading coefficient is 3. So that's one example of a type of problem that you're going to see. I think there's some other types as well. Let me click through. I don't think it's... The leading term I did by rearranging it into what we call standard form. So you look at this next polynomial here. I didn't realize these were all the same. I might have to tweak your assignment. But Bryce, are you okay, Bubba? Okay, good. So do you see how, by the way, it's out of order. Can we agree? I don't really know what words I want to choose here, but do you know what I mean when I say it's out of order? If you've been listening, then the x squared, the positive x squared, is the one that I have to write first. So when I look at a polynomial, I don't want it to go out of order. I want the x with the highest power to go first. And then I want to work my way down until I get to the non-xy ones. So far, so good? Sure doesn't mean anything to me. Sure means that you want me to stop talking. So there's yeses and nos. Do you understand that I want to put the x before the number? Okay, so yeses and nos are appreciated. Sure's just mean you're blowing me off, and I never like that. So either yeses or nos. Otherwise, I just think I'm wasting taxpayer dollars here. What's up, Tegan? Yes, it will always be the term that has the highest power of x. Yes. And so let me give you a different example. Let me head over to a different writing spot here. So like if I had like 5 minus 2x squared plus 3x. Let's all study those x's. I don't mean to ask or talk down to you, but which x term has the highest power of x? And it's not a 2x squared. It's a negative. So I'm going to put negative 2x squared first. Is everybody okay with that? The highest power of x has to lead the way. Now, we want to work our way down the chain. Who's the next most powerful x term? Yes, the plus 3x comes next. He says, I may only be a wimpy little x to the 1 power, but I still have an x, and I need to go after the guy that has x to the 2. So I'm going to rearrange and then put the plus 3x to the 1 second. And who's going to go last? The plus 5, right? And I put a plus in front of it because it was positive, and I need a plus to indicate that. So if I asked you questions about this one, first off, how many terms do you think this polynomial has? It has 3 terms. Very good. What is the leading term? Negative 2x squared. The leading term is literally the term that leads the way. After you've put it in the correct order, what is the leading coefficient? Negative 2. That's just the number attached to the leading term. And what other questions were there? Oh, and there's some words, and we need to get to these words too. So don't worry. This will all make more sense after we talk about this. So yeah, on this one, we would have said, by the way, I'll just tell you, this one's called a quadratic. It has 2 terms. Do you agree with the one that's on the board? What is the constant term? Right. The constant is literally the one that cannot change because it doesn't have an exponent. It's just the boring numbery part. The leading term on mine is what? I have to hit X and then shift 6. You guys have done exponents before. Shift 6 brings your cursor up to exponentville. Oops, X to the second, excuse me. X squared. And then the leading coefficient of my problem right there is, can you see it? 1. It's right here. Let me point to it with a blue arrow for you so you can see the number 1. And tell me if you can see it right there. Do you see it? Right. You know what I mean. Like I'm kind of messing with you. It's there. We just don't see it, but we do know that there's always a 1 in front of something by default if we don't know. Good. Okay, let's click and take a look at another one real quick. This is just the basics of polynomials. This part's kind of like, meh, not very exciting. Let's do a new problem. Look at this one. What do we like about this problem? It's already in what we call standard form. Very good. It's already in order, so I don't have to tweak this one. Great. It's going to save me like 10 seconds. So let's run through the questions. So do you see the highest power of x? Can you read that? What is it? Would you like to guess from this drop-down list what that means this is? Very good. It's a cubic. And that's just intuitive to you. If something is to the cube, to the 3rd power, then of course it's called a cubic polynomial. How many terms does he have? You can tell that because it's something minus something plus something. Those somethings are the terms. What is the constant in this case? Very good. 1/2. What is the leading term? Negative x, and then I have to hit shift 6 to the 3rd. Okay, whatever that whole chunky first term is, you just copy it in there. And what is the leading coefficient? It's invisible. It's just -1. Coefficients will always just be numbers. They're the numbers that are attached to the terms. Okay. Let's do this one, and then we'll get on to some other things here. So what do we like? It's already in order, right? It's not solved, but it's written in standard form, which we like. It's like, thank you for making me not have to do that. Here we go. So from the drop-down list, you see the power of x is 4. And you're going to see it, and you'll probably be able to pick it. What do you think? You would think it's quadratic because quad means 4. It's actually a quartic. The word, don't worry, we're going to get all this formally in just a minute. Quadratic refers to 2, believe it or not. Quartic refers to 4. So this is a quartic polynomial. How many terms does he have? It's constant term. 5. What's the leading term? Negative x to the 4th over 9. That entire first part is called the leading term. And I'm wondering how you'll answer this one. What do you think the leading coefficient is? Bryce, good job. Negative 1/9. Good job. There's a negative 1 in front of the x to the 4th that we know is there, and then we just have to pull that 9 kind of out to be a part of that leading coefficient. So you guys feel like you can tackle 5, 6, 7, 10 of those? No problems? You okay? All right. Cool. Let's see. The next section. Oh, let me get in and get you some vocabulary. So let's make this official. So when we classify polynomials, we're going to be expected to know some words eventually. So one way that we classify, so today's 308 or 38. And the first thing, we're going to be talking all today about polynomials. Like we've already probably said that word, 20 times now today. So probably have up to 100 before the end of the hour. Bless you. So one thing we're going to talk about with polynomials is how to classify them, and that is to give them names. And so the first way that we classify a polynomial is by its degree. And the degree is a fancy way of looking for the highest variable exponent. So if a polynomial doesn't have any variables at all, we say it has a degree of 0. And the name that we have for that is called a constant. So an example of a constant polynomial would be something like -4. -4 is actually a polynomial, believe it or not, and it's just called a constant. It's pretty boring. It has no x, it has no x squared, it's just a number. So that's when you're ever going to classify something as a constant polynomial, there's just no x's or anything like that. Okay? If it has a degree of 1, if you're a very good listener, like a really good listener, you'll remember from a few minutes ago, it's called a linear. So that would be an example of that would be like 3x minus 11. Do you see how the highest power of x there is 1? So that 1 is what we call the degree. So we would refer to that as a linear polynomial. Okay, now this one, I think you probably know because it's come up a couple of times. What if the degree is 2? Say it again. Quadratic. Very good. Get used to that word because we're going to spend a lot of time talking about quadratics. A lot of time talking about them. So an example of a quadratic could be like -10 x squared plus 2x plus 5.8. It doesn't matter. As long as, you could write these and never repeat yourself as long as you meet one rule, and that is that it has x to the second, and that's the highest power of x. The next power or degree is 3. And what's that called again? Cubic. Very good. And this isn't the most important part. Like this, we're just learning, like I said earlier, so that we're not clumsy when we talk to each other. You shouldn't look at me like I have 2 heads when I say, hey, look, it's a cubic trinomial. You should be like, oh, yeah, I know what that means. So cubic is 3rd degree. And an example of a cubic could be like 4x to the 3rd plus x minus 19. There it is. Look, he's a cubic. He's got x to the 3rd and no one higher. 4th degree, you saw also. Do you remember that one? Quartic. Quatic. A-R-T-I-C, quartic. And again, to write a quartic, you just have to make sure that x has the highest power of 4. And so it could be like negative x to the 4th plus 9. Yeah, there you go. Look, it's a quartic. And then the last one that we actually name, by the way, there are names beyond this. There's like sextic and heptic and octic and nonic and decic, and you can keep going, but the ones that we only talk about generally in practical mathematics, the last one that we really name is a 5. And did you pick up that from seeing the drop-down menu? It's a quintic. Very good. And an example of a quintic could be like 2x to the 5th over 5 minus 3x squared plus 194. Poof, bam, kazowie. There's a quintic polynomial. Good, good. Bless you. After this point, when someone asks you to classify a polynomial, if it has a degree higher than 5, 6, 7, 8, literally anything higher than 5, while there are names and you can find them on any website, Wikipedia would probably list a ton of them, we just stop. We just kind of throw in the towel after 5, and we refer to it simply by its degree. So if it has a highest power of 6, we would just simply call it, how unexciting is this? A 6th degree polynomial. Wow, like how inventive, right? So 7th degree, 8th degree, 9th degree. So that's that. So please, we ask you to use the words for 0, 1, 2, 3, 4, and 5. Constant, linear, quadratic, cubic, quartic, quintic. And then after that, just screw it. Just call it a 6th degree, 10th degree, whatever. Good so far? Okay. The other way that we classify polynomials is by its number of terms. And there's not very many of these, quite frankly. If a polynomial has 0 terms, it doesn't exist. So we never talk about that. Like you can't have 0 terms or you're invisible. So the lowest number of terms that a polynomial can have is 1. And this one is called a monomial. So when that word pops up, it just means a polynomial with 1 term. A polynomial can also have 2 terms. Would you like to guess what that one's called? A binomial. Trying to use good handwriting so that your spelling and everything is correct in your notes. The last one that we actually have a name for is 3, and I bet you know what it is. Trinomial. It's just perfectly intuitive with what you think it would be. So mono refers to 1 term, bi refers to 2, tri refers to 3. Beyond that, we just call it a polynomial. Okay, so if it's got 4 terms, we just call it a polynomial with 4 terms. Again, very unexciting. So we okay so far? All right, so let's practice just classifying a few polynomials. Just make sure we get this out, and then let's get to the actual mathy part of today's lesson. So if I put this up here, it's basically like playing grab bag. You're going to grab a word from the degree bag, and then you're going to grab a word from the number of terms bag. So first, based off of its degree, what would you say this is? This is a quadratic. Based on its number of terms, what would you say it is? Binomial. So this, friends, is called a quadratic binomial. There you go. And now you know. So when we use these big words, they're not bad. They're just big words. How about this one? How about negative 4x to the 3rd plus 2x minus 13? Very good. That is called a cubic trinomial. Okay. How about this one? Negative 112 x to the 5th. Very good. You guys have any questions? Again, once we leave the realm that is in your notes, so once you go past 5th degree or once you go past 3 terms, Let me give you an example of how unexciting it can be. So like if you had 4x to the 6 minus 2x squared plus 3x minus 42, there's just no, I mean, there are names. I shouldn't say there are no, we just don't use them. So this we would just call a 6th degree polynomial with 4 terms. Kind of lame, huh? But that's that. So once we run out of words, we just don't use them. We just use normal words. Any questions about all that jibber jabber? I never liked that 20 minutes. It's 20 minutes that I have to spend every year. Don't like it. I don't like anything about it. But like I said, it just removes the clumsiness from our interactions. And then if you're on the Y top and it says, um, you know, multiply this binomial, but you're like, what's a B what? It's like, oh, I know what those are. Like, don't let words get in the way of your success, basically. All right, so as I click back over to the delta math, the next thing down is rewriting polynomials in standard form. So this is just putting them in order, and I've already kind of gone through this with you. So if you see a polynomial like this, do you like its order? No. So which term would I do first? So I would do x to the 5th, then what? And then what? And then I hit submit. And like that whole section of, I think I have 5 of those for you to do, should take you like 45 seconds. So like that's all standard form means, is just to put the terms in order from highest power of x down to lowest power. What would this one be? Right. And I'm, it's kind of like you learned how to reduce fractions in like 4th grade, probably, I'm thinking. And it just became a thing that you don't even ask anymore, or at least you shouldn't ask math people. Should I reduce? Yes, you should reduce. Like the day you learned how to do that, that just became the expectation. We don't talk about it anymore. If you get 6/8, you don't even ask, you just write 3/4. And this becomes like that. This is from this point on, polynomials that are out of order, just fix them. Put them in standard form 100% of the time. There's nothing to solve. There's no math to do. Problems from this section are just literally rewriting it. So I would just put it in order. I would put x to the 3rd first. I would put minus x to the 2nd, and then I would put minus 10. All I'm doing in this whole section of problems is just putting things in order. Pretty unexciting, eh? But that is from now on like the baseline expectation 100% of the time. Any questions about that section? Okay. Now let's get to the good part, the math of this. And so for this part, you're going to see problems that look like this. So there's like a quadratic trinomial plus a quadratic trinomial. Here's a quadratic trinomial minus a linear binomial, so on and so forth. So let's take some normal notes over here and talk about how to add and subtract polynomials together. So for this part, add, subtract polynomials. So can someone write me a quadratic trinomial just quickly? I'm ready. Anything.
Negative x
Squared. Squared. Mm-hmm. Thank you. Perfect job. And it can even be quicker than that. Don't think so much. Now I'm going to put plus. Could someone write me a quadratic binomial? I'll take anything. 5x to the 2nd. Sure. Great job, you guys. And so this is how random this process is adding polynomials is just a matter of combining like terms. And so the first thing we always want to do is get rid of the parentheses. And so the first set, the first quadratic trinomial, it has a distribution of +1. So when I take off the parentheses, it just looks like this. What's being distributed into this binomial? +1. Remember, there's that invisible 1 again. And what happens when you multiply by 1? Nothing. So once again, I can just pop off the parentheses and put minus 5x squared and plus 10. And all we're going to do now is combine like terms. You always want to combine your x squared terms first, or your most powerful x's first. If you put your x squareds together, how many total would you get? you'd get -6 of them. You don't change what they are, you just change how many of them there are. They're still x squareds, you just change the coefficient, the number in front. How many x's will there be? -3x's, because the -3x in the first one, he has no date to the problem. He's like, I'm just flying solo, bro. So we just copy him into the answer. And what will our constant term be? +12, done. And that is how you add polynomials together. On the easy scale of 1 to 10, that's rocking about a 9.4, right? Okay, you think, well, gosh, subtraction must be just as easy. And it can be if you're willing to follow directions. So we're going to do, let's do like 3x squared minus 4x minus 11 minus 10x squared minus 4x plus 15. If I lulled you to sleep, wake back up, because this is where the mistakes start, right here. I got 27.5 years to prove it. Watch out. We're going to get rid of the parentheses. That's always step one with adding and subtracting. The first parentheses, again, are just free to pull off because in front of them is the number 1, and ones are pointless. Positive ones are pointless. And so I'm going to take off the first batch and just say, okay, so 3x squared minus 4x minus 11. You guys don't change. Yes, you do. And if I had $1 for every time some kid thought that, oh, they don't have to show their work on this and they missed it, I could probably retire 5 years ago. We're distributing a -1, and what impact does that have on everything that it touches? Changes all the inside signs. As they come out and free themselves from the parentheses, they all switch. You have to agree that that is not difficult, but you would be amazed how often people miss it. So what happens to positive 10x squared? He's minus 10x squared. What happens to minus 4x? And what happens to plus 15? That's the power of that minus sign. I'm going to put a blue arrow pointing to it. That minus is a killer. Watch out. Have some respect for subtraction, okay? Addition is kind of fluffy. I honestly, full disclosure, when I do addition problems, I don't even take the parentheses off. I just go, what a joke. I just combine the like terms. Minus, I take them off and let myself see the effect of that minus and what he does. Now let's just put all of our terms together. How many x squareds do we have? How many x's do we have? None. How many constants do we have? Done. Any questions on that? That is how you add and subtract polynomials. And so when I'm clicking through my Delta Math, if I see an addition problem like this, I'm sorry, math gods, I don't respect this problem enough to show work. Because what's the plus going to do? Nothing. It's just, I'm just going to combine like terms. So how many x squareds will I have in my answer? So I'm just going to have -10x squared. What will my x term be? Minus 9x. And what will my constant be? Again, because it's plus, no respect necessary. You just combine like terms. Sometimes it'll say find the sum. You guys know from earlier that sum means plus. Minus I respect. And you should too. Take it. I will never lie to you about math stuff. You should respect it. So I'm going to show my work. I'm going to take off the first parentheses and just put 10x plus 10. What is my last batch going to say? You do that, you're good as gold. You're never going to miss these. What would my first answer be that I type in? -7x squared goes for good for you guys. What goes next? Plus 5x, well done. And then plus 8. We should only now be looking at the stuff up and written in red, right? The old problem is like, hey, I don't want you anymore, right? I want the new and improved version of you. So any questions on plus and minus? It'll say find the sum. It'll also say subtract. Can you guys write this out for me as a problem? Very good. So when I say to subtract 3 from 10, I subtract 3 from 10. You have to be careful how you put them in order when you do these. So if you find yourself missing those, it's because you're putting them in the wrong order. So subtract A from B means to do B minus A. And then you just work it out, right? And I could keep clicking through here, and I think it's just going to keep being more of the same stuff there. So, all right, let's head back and look now at how to multiply. So this really is the last part of the lesson here. We got about 15 minutes, and I'm going to probably need them all. So multiplication of polynomials is really going to be the foundational piece that carries us through. So if you see binomials, they're going to look like this. I mean, it's predictable, binomial times binomial. Look, bi times bi times bi times bi. So there's a whole section of just bis and bis, because that's really important stuff. And then I've also got a section of bi times trie. See how they're all just bi trie, bi trie, bi trie. And then, of course, as you would guess, the next section, level 2, is trie trie. Trinomial times trinomial. And then the last section, which we'll get to here in a second, is bis times each other. Could be 3 of them, could be 4 of them. And I'll show you, if I can here, how to do all of this. Yeah, I'll show you. Don't worry. So let's get to it. This is how you multiply polynomials together. So thanks for hanging in with me. We're not done yet. So I know it's hard to sit here, but it is what it is. So I'm not going to give you any monos times polys because I don't really want to deal with that right this second. It's actually just super easy, but we're going to start with bis and bis. So the first section of today's notes for this is going to be a binomial times a binomial, very specifically. I say at this point, welcome now to the rest of your math career. Like, this is it. This is foundationally and massively important to just so many things now that you're going to do for the next few years of math. So let's begin. So if I write a binomial, and I'm going to, by the way, I'm going to stick with linear bis times linear bis. So like 3x minus 4 times 2x plus 9. Your parents, if you show them you're doing this at home, they'll be like, oh, FOIL. They probably learned it as FOIL back in like the 80s or something. And I'll talk about what that means here in a little bit. But for now, I want to teach you what this is. I look at it like this. This is the first binomial, and he contains 2 worker bees. Their names are 3x and negative 4. And each worker bee has to multiply by each of those targets. So let's start with 3x. This should make sense when I'm done here. If I start with the worker bee 3x, and I say 3x, go do your thing. You're cut loose, buddy. Then the 3x says, okay, here I go. I'm going to multiply by him, and then I'm going to multiply by him. Got it? We call that distribution, of course. And so let's begin. What is 3x times 2x? 6x squared. When you multiply x's, you have to power. When you multiply x's, you have to power them up. What is 3x times positive 9? So at just 27x this time, because there's only an x in one of the multipliers. Is everybody at peace so far? I now look at 3x and say, you put in a good day's work, Bubs. Because when you do an x in another x, when you multiply these 2 x's together, x times x is the same as x squared. You okay with that? Everybody okay? Kyla, you good? The 2 things in the red circles got multiplied together. Do you see how they both have x's? And when you multiply 2 things that both have x's, you need to get more x's. How many x's does the first one have? 1. How many x's does the second one have? 1. What's 1 plus 1? Does that help? Okay, let's move on to the second worker bee now. I'm going to color code him green, and his name is negative 4. And I'm like, 3x, you put in a good day's work, bro. Go home. Go play some Halo. Negative 4, you're up, dude. So negative 4 says, I'm going in, and he multiplies by the 2x. What do we get? We get negative 8x, right? It's okay. The 6, it happens all the time, but just, you know that. It's 8, it's 8. And then negative 4 heads over and multiplies by 9, and what do we get? There's 0 chance that anyone in this room is incapable of that. We all can do those basic things. All that's left to do now is put the terms together. Combine like terms, put it in standard form. Let's finish the job. How many x squareds will we have? How many x's will we have? No, these are like terms. So we have plus 19 x's, and then how many constants will we have? That is how you multiply binomials. Let's go again. Second verse, same as the first. It's a four-step process. It will always be a four-step process. So I'm going to color code this as deliberately as I can. I have 4 colors to use. How convenient. Here it goes. What is x times 2x? 2xx, 2x squared. So again, we got to power up the x because there's an x multiplying by another x. Switching colors now. Follow the blue connector. What is x times 3? So I'm going to put plus 3x. I'm switching colors again. And if it helps you to stay organized, you can also put your multipliers underneath like this to kind of keep your paper tidy. What is negative 11 times 2x? Negative 22x. And of course, I have one more color. What is negative 11 times 3? And dudes, all you got to do is hope you don't do anything stupid along the way. And now you just put your like terms together. I will have 2x squared. How many x's in the middle? Negative 19. And then minus 33. Done. That is how you multiply binomials together. If you hear your parents ever say this word FOIL, I don't teach FOIL a lot. I just feel like I have to say it because you'll hear it from somebody. Oh, you're foiling. It stands for first, outside, inside, last. I don't teach it a lot because that's not going to help us with the last part of the notes today, but it does work with by times by. So the F stands for first. That means you take the first thing in the first binomial times the first thing in the second, right? That seems logical. The O stands for outside. So that means now as I look at this problem holistically, x and 3 you see are on the outside of the problem. What do you, and the I already said, what does that stand for? So that's the negative 11 multiplying by the positive 2. And then the L stands for last, and that's the last thing in this binomial multiplying by the last thing in this. I mean, I can't believe like books have been written about this. It's ridiculous. So if you hear someone say FOIL, or if I say like FOIL that out, I'm just talking about multiplying binomials. But if you never ever say the word FOIL again, other than like wrapping up a leftover steak or something like in tin foil, I'll be perfectly fine if you never say that word. All right, let's expand it now. Let's make this harder. Let's now move on to a binomial times a trinomial. It's not going to get harder. It's just going to become more laborious. So an example of a problem like this would be like 3x minus 5 times x squared plus 2x minus 7. Can't disagree with that. That's a binomial multiplying by a trinomial. Let's get to it. If you've been paying attention, you can answer this question. Big brain question coming. How many multiplication problems is it going to take for me to get through this? How many worker bees are there? There are 2 worker bees. Their names are 3x and negative 5. And how many jobs does each worker bee have to do? 3. 2 workers, 3 jobs each. Last I checked, that's 6 jobs to do. So let's begin. I'm going to take the 3x and I'm going to distribute him very faithfully. I don't have enough colors, so these are all going to be red. I'm going to multiply there, there, and there. So are you. So it's okay if you missed this the first time. So what will my first answer be? 3x to the third. You might go, what the heck? Where did you get 3? And I'm going to say the same thing I said 5 minutes ago. How many x's are in my worker bee? 1. How many x's are in his target? And what's 1 plus 2? Oh, yeah. So you always got to keep all your x's accounted for. If you have a guy with 2 of them, multiply them by a guy with 3, you're like, I better have 5, right? Yes. I'm not worried about any other x's. The only x's I'm worried about right now are those ones. That's the only multiplication problem I just now did. And the first worker bee has 1x. His target has 2. 1 plus 2 is 3. You're looking elsewhere, aren't you, at this point? Because I have to get there, because they're coming up next. So it's time for the second red connector, everybody. So let me erase my first red connector. I'm sorry, maybe I shouldn't have drawn them all at once. It's time for the second red connector. Is that better? Okay, let's go to the second red connector. What is 3x times 2x? 6x squared, because now I got 1x multiplying by 1x. 1 plus 1 is 2. And now let me erase this connector and let's head to the last one. Here we go. Follow the red line. Boom. What's 3x times -7? Negative 21x. And I can now say 3x, you put in a good day's work, bro. Get on home. Go get yourself a glass of iced tea and go take a nap. Nice job today. So I'm going to erase this worker bee and say he served us well. And now it's on to the second worker bee, whose name is -5. So follow along. What is -5 times x squared? I want you to note where I'm writing it down. Once the problems start to get longer, I like to organize my answers like this. I like to put them underneath each other because the like terms get a little bit harder to spot. Okay, I'm erasing that connector now. I don't want any confusion. And now it's time for worker B -5 to move on to his second job of the day. What do we get? -10x, and I will, of course, put it underneath its like term, the guy with the other regular x. And then it's time for worker B -5 to do his final job of the day, which is... And now, friends, it is time to combine like terms. So here we go. How many x to the thirds do we have? How many x squareds do we have? Minus 31 x's. Done. You okay there, Zainer? You sure? You cannot, because this x to the third is not the same as this x to the second. Those are not like terms. To be able to be combinable, you have to have the same letters with the same exponents. That's the key. You can only put them together if they're the same. And you guessed it, we also, of course, have to go down the road of try times try. And again, it doesn't get more difficult. It just becomes more annoying. More chances to boo-boo. So here we go. Let's do x squared minus 5x minus 1 times 3x squared plus x minus 3. How many multiplication problems, big brainers, will it take to get through this? It will take 9. There are 3 workers, each of whom has 3 jobs to do. So let's begin. I will only draw one connector at a time. Promise this time. First worker B, his name is x squared, and here he goes. He's going to work. What is x squared times 3x squared? 3x to the 4, because there's 2 x's targeting 2 x's. 2 plus 2 is 4. Moving on to the second connector, it is x squared's turn now to say, here I go, here I go, here I go. Boom, what is that? X to the third, because there's 2 x's targeting 1x, making a total of 3. And then finally, we're going to move all the way across. We're going to take x squared all the way across to -3. And what are we going to get? Minus 3x squared. And it is time for me to send x squared home for the day and say, bro, go get yourself a burger. You've done well. Let's let -5x now do his thing. So next worker B up is -5. And here he goes. What is -5x times 3x squared? So I'm going to make sure I put that underneath the other x cubed. Okay, what is negative? I got to keep erasing these. What is -5x all the way across to x? Good. And then what is -5x all the way across to -3? Yeah. They're really, I mean, the only way you're going to miss this is if you do knucklehead stuff, like say 5 times 3 is 8, 4 times 2 is 6, 1 plus 2 is 4. I mean, it's just the same stuff over and over. It's time for me to say -5x. Thanks for your hard work today there, bro. Go on home. Go buy yourself something nice. It's time for -1 to do his thing. What is -1 times that? And I can't keep erasing these because the clock is telling me I don't have time for all this. So what is -1 times x? Negative x, -1x, call it whatever you like. And then what is -1 times -3? And then the final step in this process is for us to join all the terms that we can. And if you organize like this, you never have to search because look at them. They're zoop, 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 zoop. They're in a dang line, man. So we're going to lead our answer with 3x to the fourths. We're going to do -14 x to the thirds. Ooh, x squareds. We got a ton of those. How many will there be? -11 of those. How many x's will we have? And constant term will be jackpot. So that would be a quartic polynomial with 4 terms. The clock is telling me that I do not have time to get to multiples, so I will modify your assignment to reflect the fact that we did not get to finish. So tomorrow's assignment will cover all the stuff we've talked about today. Got it? Help each other out, too. I don't want to come back on Monday and have you be like, I couldn't do it, or have Miss Lloyd say, such and such wasn't working, said they didn't know what they were doing. Don't give me that nonsense. You guys help each other out. Let's get through this, all right? Cool, cool.